Okay, let's review what we did today to make sure that you got your homework done. So, we're going to start right here, step number 1. We got to do PV equals nRT and solve for the number of moles of gas. Because remember, the assumption is at that low temperature, there is no water vapor in there. So we are only finding the moles of air at that low temperature. You should get a number with several zeros and a small number like that. Okay, a really small number of moles. Because in that little tiny bit, not very many moles. Then we take that many moles, and at each different temperature, so at all the other temperatures, so at 50, 55, 60, 65, all the way up to 80, you're going to have to do this equation and these calculations at each temperature. So you're going to do, you're going to take this number of moles of air, plug it in there, and you're going to be solving for the pressure of the air. Right here, you're going to be solving for pressure. And R in this case is going to be 62.4. And remember, temperature needs to be in Kelvin, and your volume has to be in liters. Remember that up here too, your volume has to be in liters, so you have to convert that. So you're going to solve for the pressure of the air. Now, that is just the pressure of the air inside of the test tube. And so when we're trying to figure all this out, we're saying that in this test tube, right here, there is pressure of air and there is pressure of water. And all of this pressure in here is equal to the pressure of the atmosphere outside. Okay, and so the pressure outside on the day that you did it was 765 millimeters of mercury. So then we can use this simple little equation to solve for the pressure of the water. So on your data sheet on OneNote, pressure of the air at each different temperature is a column. You'll have to do PV equals nRT like 10 times for each one of those. Then you're going to have to do this equation, pressure of the water, that's the next one over. Now pressure of the water is what we're going to end up graphing, okay? And so you're going to have to graph the natural log of the pressure of water. So you're going to have to do this calculator at a time. You're going to have to go the natural log of the pressure, and you have to put the actual pressure of the water in there. So it'll be a small number of millimeters of mercury, I don't know, let's say 60, okay? And you're gonna graph this on your y-axis. You'll have to punch that in on your calculator. The natural log of 60 for my example here. Natural log of 60 is 4.09. So I would plot that 4.09 on the y-axis, and then on the x-axis, if I'm saying that this is my 50 degrees Celsius one, I'm going to take 1 over 50 plus 273, because I have to convert this into Kelvin over there. So 1 over the inverse of that. So if I'm going to graph that, 1 over 50 plus 273.15, that value is 0.003095. And that is your x-axis, 1 over t. Okay? So your point that you would graph is 0.003095 and 4.09. Okay? And so you're going to end up with points for these for everything between 50 and 80 degrees. So 50, 55, 60, 65, 70, 75, and 80. And you're going to graph those. Once you have those graphed, then you need to get a linear regression. Okay, and so we are going to be using an XY scatter plot. So you're going to go to your Excel, plot all those points, and you're going to put in a scatter plot. And then you're going to have to add a trend line. And to that trend line, under the options for trend line, you're going to have to, first of all, make sure it's linear. Add the equation and add the r squared value. And so you're going to come out with an equation, and the graph should look like a negative slope, something like this, okay? Where this is 1 over t, and this is natural log of pressure, okay? So then we're going to take this graph, and this, so I'm just going to say this equals negative 2x plus 10 is my example here. knowing that this equation up here fits into this format, where y is the natural log of water, okay, and the slope is equal to negative delta H vape over R. Now this part, this is the part that we are trying to solve for. We want to know the heat of vaporization of water. And so I know that M is equal to negative delta H heat of vaporization, which is our variable, over R. And since this is now a physics problem, the R that we're using is the kilopascal one, which R is now equal to 8.31. That's the constant for kilopascals. So once you have the slope, in this case, -2, is equal to, because M is -2 from right there, is equal to negative delta H vape over 8.31, multiply it across, I get negative 16.62 is equal to negative delta H vape, and so the heat of vaporization of water would equal 16.62. Now the unit for that one is kilojoules per mole, and I put on your OneNote that the real accepted value is 41 kilojoules per mole, and so then you would need to do a percent error based on that. And if you remember, percent error is absolute value of did minus shoulda over shoulda times 100, where your shoulda is 41 in this case, okay? And so your job in my absence is to get all the way down to your percent error. How close did you get? And then we'll compare it to what Jackson gets, and we'll prove him wrong. So anyway, if you guys are having trouble, text me 406-531-8599, and I'll try to get back to you as I can. Good luck.